Okay, welcome everybody. We're going to do chapter 2 now. So it's about organizing data and graphing data. So you get a big set of data, imagine like a whole, I don't know if you know what a phone book is, but a whole phone book of data. And obviously you can't really do too much with it. So I know you want to organize it somehow. So that's what this is about, how to organize it. So we start out with what they call raw data, which is like a big phone book of data. For example, here we have the ages of 50 students. So it's kind of, and imagine it wasn't 50 students, but it was like, 10,000 students, and it would just be a huge amount of data, and you just sit there and stare at it. You wouldn't know what to do with it. Or here's another example. We ask them about their status. Are they first year, second year, third year, or fourth year? And you get this information. So this one is quantitative raw data. Let me make this bigger. So this is quantitative raw data here, and this is qualitative raw data, or categorical raw data, because we have categories, right? Like first year, or called freshman. Another category would be sophomore, junior, senior. So those are categories, so that's called categorical. And they refer to this as ungrouped data. Data containing information on each member of a sample or population individually. So we might try and group it, maybe, and then we might say, okay, there are, 30 juniors and 10 sophomores and so on. So we might try and group it. Okay, so that's called raw data. So we want to get away from raw data, basically, and organize it somehow. The first thing we do is what we do this kind of thing here. So type of employment students tend to engage in. So private companies and businesses, federal government, state and local government, own business. So now we're kind of organizing the data into types. Let's see. So a sample of 100 students enrolled at the university were asked, what do they intend to do after graduation? 44 said they wanted to work in private companies. 16 said, okay. So we get these kinds of responses. So we can say that type of employment is the variable. And so we ask the students what type of employment, and there are different possible answers. So these are the different possible answers they can give. So this is type of employment is definitely, these are not numbers. Now these are numbers over here, but this is completely different. This is the number of students. But the type of employment is the question. So I say, what type of employment are you going to work at? And you'll give me one of 4 answers. So we call that a categorical variable, or a qualitative variable. Now, in this text, they're not saying this, but we usually call these the different levels of the qualitative variable. So quantitative variables have different possible values. So I might ask you what your age is, and there are lots of different answers you could give me, lots of different numbers. So we say that variable age has different values. But when we can also say that a qualitative variable like this one has different values, but we usually refer to them as different levels. Okay, either one is okay, but you should know both words. Now, along with the different levels here, or different values, we have the frequency. We call this column the frequency for our particular set of data. We had, 100 students. So these are the 44 said this, 16 said this, 13 said that. And the sum of these numbers is 100, of course. And this is called a frequency distribution. A frequency distribution for qualitative data So this is qualitative. If I asked you age, it wouldn't quite work this way. But for this one, it works, right? We say, I'll explain what I mean by it doesn't quite work for quantitative variables, but for qualitative, we can list the different categories and then just count how many of our data points, how many of our objects were there in this category, in this category, in this category, in this category. So a frequency distribution for qualitative data lists all the categories and the number of elements or the number of objects that belong to each of the categories. So this is called a frequency distribution. So I might ask you in a quiz, is this a frequency distribution or not? So how do you make a frequency distribution table? Well, it's pretty straightforward, but suppose you have a sample of 30 employees from a large company, and you ask them how stressful their jobs are, and you don't ask them, is it 1, 2, 3, 4, 5? You don't want those kinds of answers. Rather, you're gonna let them reply by saying very stressful, somewhat stressful, none. So you get these kinds of responses, okay? And then how do you construct a frequency table for this? Well, it's pretty obvious. You have the variable. What's the variable? First of all, let's ask that. So this is a kind of question I might ask you. I'd say, in this scenario, what is the variable? So what is the variable? How stressful, or stress level, or something like that, right? That would be the variable. Let's call it stress level. Okay? And what are the levels, or what are the values that this stress level can take? So we're only allowing 3 values: somewhat, none, and very. Okay? So now we have the levels, we have the variable and the levels, and now we want to make the frequency distribution, which means we want to count up how many are in each category. I'm sorry, how many are in each category, or how many are in each level. Okay, so that's what we do. We say, here's the variable, they call it stress on job, and these are the different levels, and then we count up how many were there. You know, we say, okay, there was one, there was another, so we count up. We get that there were 10 varies in here. We get that there were 14 somewhats and 6 of these. So this is called, the whole picture here is called the frequency distribution of stress on job. Now this column here is called the frequency, but I might be interested in saying, well, it was 10 out of 30, which is what, 33%, right? 1/3, right? So I might like to say, oh, that's 33.3%, and I might like to say this is 14 out of 30, and this is 6 out of 30. 6 out of 30 is 1/5, so that's 20%. I don't know exactly what this one is, but I might be interested in dividing the frequency by the total sum, by the total or the sum. And when you do that, the new column that you get, where you get 33.3% here, you get something here, you get 20% here, that's called the relative frequency. That's called the relative frequency. Okay? So relative frequency is what? The frequency of the particular category, so 10, divided by the sum of all the frequencies, divided by 30. It's a percentage. Okay, so the percentage is the relative frequency times 100, of course, right? So if for example, here I said this was 6 out of 30, so that's 20.20, and usually we call that 20%, so we have to multiply 0.20 by 100 to get 20, right? So that's what they said. They said you have to take the relative frequency 0.2 times 100 to get what we call the percentage, which is 20%. Okay, so they do that here, right? The relative frequencies, when you add them up, give you 1, and the percentages, when you add them up, give you 100. Okay, now we'd also, I'm sure you've seen lots of pictures, graphs of this kind of data. So we want to make a graphical presentation of our qualitative data. So we're focusing now on qualitative data, right? That's what we've been talking about. So we can make what we call a bar chart. So that's pretty straightforward. Here we have this is the variable, again, is stress on the job, and the levels or the possible values for stress on the job are very, somewhat, and none. And so very was whatever it was. What was very? 10. So that we draw a bar of height 10. Somewhat was whatever this height is, and none was 6. Okay? So we can make this what's called a bar chart. Okay? A bar graph. They call it a bar graph or a bar? Yeah, bar graph. I'm sorry. A graph made of bars whose heights represent the frequencies of respective categories is called a bar graph. Okay, so the heights of these were the frequencies, right? The y-axis here is the frequency. Now, next one we're going to do is we're going to have the y-axis be the relative frequency. So instead of 6, what did we say? That was 6 out of 30, so that was 1/5, which was 20%, or 0.2. So we're going to have the relative frequency. So this won't read 6, this will read 0.2. So the height of none will be 0.2. Okay, so this is not so. You can read these. I'm sorry, the next one they're going to do is not the relative frequency. They do? Nope, they don't even do relative frequency yet, but you certainly could do relative frequency. Okay, but here so far they've just done the bar graph. So what's the difference between a bar graph and the relative frequency graph? It's just that here we have frequency for the bar graph, and relative frequency is different. We'll come to that later, I guess. Okay, let's do a pie chart. What's the difference? Or what is a pie chart? Well, pie chart looks like that. Okay, so we have 20%, 33% for very, and 46.7% for somewhat. I guess that was the other number. So they said, as we know, a circle contains 360 degrees. To construct a pie chart, we multiply 360 by the relative frequency. So 20% of 360, right? So 20% of 360 is 72 degrees. So that tells you how many degrees to make this one. Okay, so here we have a bunch of questions. I think you can go through these yourself. You have the answers here. I don't think this material, I have to spend too much time talking about this. Okay, that's the end of section 2.2. I'll start a new video for 2.3.